Well, hello, everybody. Thank you very much for joining us here at 9.Connects. This is Paul Taubman, and you are in the right place if you are here for our webinar today on the SOS of library scrubbing. So with that, I'd like to get into this presentation here today and give you what our objectives are going to be. First and foremost, I'm going to talk about the structures that are available for library management systems that are currently out there today. I think the good news you're going to find is that these systems are continually improving. And I think over time, you're going to see more and more great things that are out there. Right now, I'm just going to show you what's currently out there because obviously we got to get our day-to-day jobs done. The second thing is the elements that make up what we'll call a library scrub. So we want to talk about what I'll call the 5 key elements that you have to go through when you're actually going to go through a library and give it the once-over to make sure that everything is proper and set in place and provided information where it's missing. And the next one over here, and we're going to look at the time commitment required to scrub a library. And I'm really excited about this. This is a very unusual webinar for me. Normally, of course, we're always showing some type of demonstration or we're showing our knowledge on something, and obviously this is our knowledge as well. But the data I'm going to provide you is from a survey that we did with 6 of my colleagues to give you some real numbers behind the effort it really does take to put together, or in this case, scrub an existing library. So with that, let's talk about the grand vision. The grand vision is really important because why are we trying to bother with this to begin with? Why are we putting in this time and effort? And as you can see, it's a bit of all of that in order to do this here, but we're doing this for several reasons. And the big one, I think, is really just usability. If I've already put the effort into building a symbol and a footprint and giving it its parametric information, I would want to share that with everybody else because I don't want them to duplicate it. And when we get duplications of the system, it causes problems down the road. We want a single source of truth as well, so that we know that when we pull from a certain site or location or container, I'm going to call our library management type tools out there containers. When we pull from it, we know that that information is good. I don't have to second guess it. Consistent yet simple processes for new parts. So when we have to create a new part, can we easily create what we've already got created? And what I've seen all too often is that a lot of people put a lot of great effort into getting their library together, but then the addition of another library part is a monumental effort. So we want something that's consistent yet simple. And lastly, we also want a simple library that is easy to maintain, because all of us, one way or another, unless you come from a Fortune 500 company or you really have a management that understands this whole process, more than likely you don't have a full-time librarian. So as a result, that's kind of one of the hats you're going to have to wear as a designer or a developer in the PCB process. So then why is this so difficult? Now, putting aside the reuse, which to me is just the grand scheme of things, I don't think there's really any downside to reusability. But when we talk about something like the single source of truth, okay, well, what's the issue with that? Well, one of the problems is we really have to validate each new part that we put in there. So the best thing that you can do is someone creates it and another person looks at it to make sure that 2 pairs of eyes have been on it and that they agree that everything looks good here. The other issue that's really problematic with the single source of truth is that there has to be a synchronization generally with the purchasers. And that could also be for the CM people or manufacturing as well, but usually it's with the purchasers. And the problem that we've always seen here at 9.Connects is that normally these containers that we're going to put our library parts in are separate from the main systems, the financial systems of the company. Of course, that's where the purchasers lie in. So there's always going to be a lag. If you introduce a new part, they're not going to see it until you introduce the bill of materials. And that's why we've always said in past webinars, and it bears repeating, get that bill of materials to your purchasers as quickly as possible because they have to start their process of reviewing the parts as well. The other issue is that they may find things, and in the project you fix things, but it doesn't make its way back to the libraries. And that's a big issue. If something is obsolete and it doesn't make its way back into the library, sure enough, someone's going to use that part again, and you're going to go through the same process of trying to fix that again. So that's a kind of a big issue with these type of libraries when we've got something centralized and it's not a part of the main purchasing system or the main financial system of the company. But we just got to deal with those type of things. Let's jump over here. In terms of the centralized library, we want a consistent yet simple process for new parts, right? That's one of our objectives over here. So that brings up the question of a gatekeeper. And the problem I've seen with gatekeepers is that you have to find this really good balance between non-existent to draconian. If it's non-existent, then all you're doing is paying for an expensive container. You're putting a bunch of stuff in there. Everybody's going to do it their own way, and you really didn't accomplish anything by doing it through that method. I used to call it libraries by democracy, but actually there was no voting on it. It's really libraries by anarchy, and everybody puts it in the way they want to put it in, and there's no organization to it, and all you've done is just paid for that container that's just maintaining this mess of parts. As you'll see later on in the webinar, it's like if you purchase a $15,000 trash can that's gold plated and you put garbage in it, it doesn't make the garbage worth any more valuable than the can itself. There's the opposite end of that where you're draconian about it, and some companies really have to do this. But as I found in companies that do that, especially if they're using Altium Designer, what you're going to get designers who's saying, I can't work within the system, I've got to get my job done, and then they go off and they create their own libraries, hoping at some point that they can be forgiven for that and that they can have their stuff brought into the library system. Those two extremes just simply don't work in centralized libraries. You've got to find somebody who's willing to be the gatekeeper, but at the same time have some discipline. Let me take that back. They're allowing people to put stuff in, but at the same time have a discipline so that it's not just running amok. So that's what we're talking about here with the gatekeepers. There's also a need for external tools, and this is kind of problematic to me. When I've looked at flows of different companies, you look at what they're doing and say, well, we can put this in here, but then I got to communicate this to another person. And in a lot of these tools, that means you're going to have to go to a separate tool like an email, or you're going to have to go to Instant Messenger. As a result of this, we have things that don't really follow a clean path. I'll give you a really great example. There's one time I remember there was 3 of us that were working for this particular company. We're all librarians, and we said, well, if you need a part done, send it to all 3 of us. And that sounds reasonable, right? But then we had to send emails back to each other as to who was going to take which part and work on it. So those are the little things that really trip you up. Or even obtaining a serial number, a company serial number, that can be a major undertaking as well. So if maybe the purchasers have those numbers, then they may give it to somebody to maintain, and unless you keep harping on that individual to give you those numbers over there, a lot of times they just throw the list onto a shared drive, say pick the numbers you want, and that even becomes a massive mess as well. So the littlest things that you think would be very trivial actually become rather complex, and that's because we have to rely on external tools to do this whole library management thing. And of course, this one, I think we've pounded this into you in so many different webinars, just you got to be consistent. Consistent part name, consistent, and a consistent value here at all times. So that's the thing that you want to make sure of. If you have consistent parameter names, and this is one thing that these centralized containers do a really good job of, ultimately you're going to create a field name, which is your column, and that's going to make sure that everything falls into the right column. And then with the consistent value as well, it's just a matter of typing something so that it follows suit with all the other data that you already have for that column. Okay, it needs to be, the thing we want it to be is to be easy to maintain, right? Well, obviously you just can't leave this alone. There is the garden analogy here. So here's a particular example of a garden that, again, you can see that it has to be tended for, otherwise there'll be weeds or there's gonna be pests. And you see already here that a pest already got to this particular plant over here. So there has to be somebody who's constantly maintaining the library in a similar fashion to the garden analogy here. And that has to maintain that not only is just maintaining it to make sure that everything looks the same, it talks about, we're talking about the creation of the components, and more importantly, the validation of the components as well. And that's why let's put it this way, you know as well as I do, when you create a library part, there's so many ways to do it. And so if everybody does it their own way, they're not going to look the same. And you'll see, I'll make reference to this here a little bit later on. We actually talk about the scrubbing of the components themselves. Okay, I do have a polling question for you, and I'm just kind of curious to know. Now, we've been calling them, as I said, containers at this point, but I'm just kind of wondering, you know, what does your library container, basically, what are you using for your libraries right now? All right, so we got the results back, and they're very interesting. They're really an interesting spread across the board there. I'm also kind of surprised that a lot of you are using databases, which is a really good thing. We'll talk about these different types here in just a moment. But yeah, this is a really interesting spread. So hopefully you'll see some things that you didn't know about the other types of systems that are out there as well. Okay, so as I mentioned, I keep calling them containers, but what are we defining as containers? What I'm going to talk about briefly here today is integrated libraries. database libraries, and then what I'll call a next generation of database libraries, component management database libraries. Talk about Concord Pro and PDM. So what I want to do is show you the benefits and the disadvantages of each one. So none of them is that perfect utopia of library containment. There's always going to be some trade-off between the benefits and the disadvantages of each one. And by the way, as a side note, if you look in your panel over there under handouts, the stuff I'm going to talk about today was also written in a blog about a month ago. So if you want to take a look at that, feel free to download that from the panel that you've got. Okay, let's start off with integrated libraries, because I think these are somewhat underrated in the sense that they can definitely provide a service to a group of engineers. So let's take a look at their benefits. Number one, there's just no additional cost to them. They already are built into Altium, so you don't have to pay any service. You don't have to pay for anybody to, to help you install it or to maintain it or subscriptions. It's just built into Altium. And the library update is simply a swap of files. So what a lot of people will do here is they'll partition off some type of, partition some part of their drive, and that area is where the librarians can go in to work on the various files. And then in Altium Designer, they'll take those files that they worked on, the symbol and the footprint, and they'll compile it into what's called a .intlib. That .intlib is put into a public area, and as long as they maintain the exact same name, all they need to do is just update the file that's already in this public area, and everything will work really smoothly, because Altium just points to that file and it points to the name of that file and the location of it. So if you swap it out, it really doesn't care. It doesn't get interrupted, and you just continue to move on through that method over there. So it's kind of seamless to do that. But there are some disadvantages to this. What we have found is you really do need to have practically a full-time librarian to maintain this. And it's also not that easy to work when you've got multiple contributors as well, because even though, again, this is one of those things where somebody has to put in a request through an email, you got to work with the different contributors. You don't want to open up the same library somebody else is working in. So there has to be a lot of discussion or communication between those who are doing the libraries if you are going to do this. And of course, you kind of lose a little bit of inefficiency. You lose a little bit of efficiency in the sense that, if you have 1,000 resistors and you want to add another resistor in there, we have to copy that same graphic again. Whereas in a database, one resistor can represent as many resistors that you have in the database there. So, but it doesn't really take up all that much space, but it's kind of nice to know that every single time you create a resistor, it's going to use the exact same symbol. All right. Let me talk about databases, because the remaining ones I'm going to talk about are all database based. So no database product is perfect. They all require some type of administrator. There's just no doubt about it. The amount of administration is going to be varied upon the system that you're going to look into or purchase, and we'll talk about those here in just a moment. Databases are textual, and you can see that up here. So they don't contain the actual symbol information or the PCB footprint information. They provide links, so they'll tell you a path to where you can find it and the file name where it can be found and the actual name within the file itself. But in terms of the actual primitive information, those are kept in separate files. And that does cause a little bit of an effort to try to maintain all of that. Databases have to be hosted on some type of platform, usually on the cloud or on a company server. So most people probably operate off a company server for proprietary reasons, but there's also the opportunity to use cloud-based services as well with these. All right, let's talk about the benefits of the database in general. So let's talk about databases in general. So I'm not talking about like L9 or Concord Pro yet. I'm just talking about if you were to do even an Excel sheet, Microsoft Access, SQL, MySQL, an Oracle database, just databases in general. So there's definitely that reuse of component graphics as we talked about before. It is very easy to clone a component. So if I go over here on line 15 and I have another potentiometer and maybe this one's 5K, it's easy enough for me to copy that and then just change a few extra cells over here in that new record within the database, and now I've got a new part, and assuming that the symbol and the footprint remain the same. So it's really that easy to create another part or to clone it. And parametric information, name and value will be much more consistent. So when you look at this over here, and again, even though this came from a bill of materials in Altium, it's almost the exact same thing that you'd find in any type of database, right? You would have your description columns, your manufacturing information. So each one of your columns is your fields, which would be your parameter names, and each one of your rows would be your records or your components. So if you looked at enough bill of materials or even the parameter manager in Altium Designer, you effectively know what a database looks like. And you know that when they're all organized, it's easy to read, right? And that's what you're trying to gain with this with a system of this nature. So what are the disadvantages of them? Again, you need an administrator. You just really can't get away from that part of it. And you need, there has to be a knowledge for database management. So when you purchase something, even something like Microsoft Access, it's not really a trivial program. There's a lot of things that you can do with it. And the more complex the system is, obviously, the more information you're gonna need to know about how to manage that. How do you wanna set up your tables? Are there certain links that you wanna have? And even though you don't see it on the Altium side, but there are these things called one-to-many or many-to-one. And if you don't do your tables correctly and you have something called a many-to-many where one table represents one thing and another table represents another thing, you can really turn it into a tangled web. So you got to have some knowledge of database management to run this. But in addition to that, you got to have component management too. So you're not just learning how to operate the database, you're trying to operate the library itself that's trying to reside within this database. How do we organize the database so that it works for our components? That's really the question there. If you can have everybody just access it directly. When I say access, you access whatever database that you have. That's a little bit dangerous. A lot of times it's a lot better if there's some type of form that they can go through in order to enter their information into it. And that means that you're going to have to create those forms because Access will allow you to create those, or these other tools allow you to create them. However, they don't know anything about component management because they're generic all-purpose databases. So you got to create the GUIs that best work for what your company needs. But that also means you got to distribute those GUIs too. And how you're gonna have to do that, you're gonna have to work through your IT, or you're gonna just have to be a pretty decent programmer to do that. And I kind of assume that most of us out there who are doing design really don't have time to go to this level of creating GUIs. Tracking is lacking. So if somebody makes a change in there, you're not really gonna find who made that change. So that's kind of a little bit of an issue with these general databases. The larger ones can do it. The kind of the more simplified ones really aren't going to track a whole record of who's made what change where. And then of course you've always got your graphics need to be synced with the database. So it goes back to what I said earlier. You've got your symbols, you got your footprints, and now we've got to make sure that our database knows where that symbol and footprint library is residing within our system. Where those come into a little bit of a play is that somebody creates a part, and now how do we get that part into our database, both in terms of its textual information and the footprint and the symbol as well. So it takes a little bit of administrative effort to do this. Not impossible, but there is an administrative element to that. Let's talk about what we call component management databases. So to give two examples of this is L9 from 9.connects. And then our good friend Randy Clemens also has one out there. It's called Parts as well. So these are two really great examples of a component management where, yes, it's on a database, but now I don't have to create the GUI interfaces or to set this up in relationship to my components. So here's an example of Randy's products. It's Parts. It builds itself on Access and MySQL. So you do have to purchase those separately, but you can build it on top of, or you purchase his on top of the Access, the MySQL or MySQL service. It's one or the other. You don't have to do both. And from there, you can automatically get what you need in order to make use of the component side of the database. It is definitely off the shelf, and if you're interested in it, there it is right over here. So we thought it's a pretty cool product. We took a look at it and we said that, yeah, this is a neat product for those people who have a library and you've got maybe some limited funds and you know what you're doing. Just, I'd say, if you want to get started somewhere, really cool offering. We also have ours here at 9.connects. And this one is a little more, I'll call it more enterprise level. It is self-contained, so you don't have to buy a separate database for it. So our database comes with our product over here. However, we're trying to do it for a larger group, and so we also do provide training with that as well. But what are these offerings all about? The benefits. So these are the same benefits you have with any database. But in addition to that, now somebody's providing you the forms. You don't have to create the forms yourself. And then there's also version control in these systems so that if somebody makes a change, you know exactly who made the change and where and when. There are also these things we'll call component templates in there as well. Now, in a sense, a database can provide those component templates, but the idea behind that is that if I have, for example, a section for diodes and I know what I need to put in for diodes, if I have a section that's for ICs, I know what I need to put in for the ICs and so on and so forth, because none of the components necessarily have the exact same parameters that we're always looking for. So there we go. So what are the disadvantages to something like L9 and parts? Again, you kind of sort of need an administrator for this. I'm not saying you have to be full-time, but somebody's got to maintain this here. There is still a need for component management here. Fortunately, it's not having a need for database management. And the graphics still need to be synced with a database. So you got to know where is it in your system? What are the names of the files? And what are the names of the parts for both the symbol and the footprint? So those disadvantages are still there. Let me jump over here to Concord Pro. So this is the one that we actually have to thank Altium for this. Library management has been something I've been dealing with for over a decade now. And now that they've really been pushing Concord Pro as a component solution, that's what's really driving a lot of interest. And because of that, that's where we're starting to see ourselves helping out customers and trying to, sound the alarm that libraries really do need to have some type of organization to them. So we are definitely excited about Altium's effort to push this because it's bringing this important message out there to the community. So what's the benefit of it? Well, all the things I kind of listed before, but in addition to that, they handle the synchronization of the database and the graphics within. And what I mean by that is if you create a new part, and then let's say it's the end of the day and you save it off and then you come back, all you need to do is just save it. You don't have to tell it where to save it. When you come back the next day and you open up your Altium Designer to go into Concord Pro, well, guess what? Your part is already sitting there in the projects panel. You continue off where you left off, and when you're ready to push it in, then you just release it to the server. And at that point, it will take your symbol and your footprint and the component information, and it will store it accordingly within the system itself. You don't have to worry about that. And to me, that's a nice feature of Concord Pro. The other thing that's always nice about it is because it's built within the Altium environment, they can give you dynamic information real time. So if you do place a part down and you've done what's called part choices, you place it down, you put your cursor over it, you're gonna get the stock price and you're gonna get the lead time in real time. So you know that you're not guessing as to whether that part is currently out of stock or if there's a lead time involved with it. What are the disadvantages to it? Needs an administrator, and to be honest with you, in terms of administration, far more administration than a database or a component management database would require. So there is definitely a lot more here. Because what Concord Pro is not really telling you is that it's not just for components, it's also for any file within Altium's domain. And by the way, it can also store non-Altium files in it as well. It's really on the verge of what we call a PDM, and I'll talk more about that here in just a moment. Knowledge needed for component management, again, you really can't escape this. You've got to know how components are going to be organized in order for this to work. And more so, you kind of have to get it set up correctly from the get-go. They have their own file structure. So yes, they have their folders, but within their folders, each folder has its own purpose, and those folders also have their own features and functions as well. And then there's also this thing called the item ID naming convention, which you kind of want to get right from the get-go, because this ID is very similar to those things in a database. Every single database row or record, which is your component, has to have something unique about it. And that's how Altium handles that within its system. The thing is that once you've created something with an ID, and if you don't like it, you've actually got to delete the whole thing because you cannot remove that ID. You can change the name in a revision, you can change the description or anything else in a revision, but once that ID has been assigned to this, that's it. So if you made a misstep where it's like, well, wait a minute, I didn't use the ID I expected it to use, then you got to delete it and start it again. So that's kind of one of the disadvantages of that. Let's talk about this thing called PDM for a moment. So again, well, actually, before we get into the benefits, let me talk about what it is, because a lot of people have probably heard of it. Pardon me, it's product data management. I've been calling it product database management, but it's actually product data management. It is a combination of a database, so there's still a database in there, and a file directory system similar to what is found in Windows Explorer. And here's kind of an example of one that you would find in SolidWorks PDM. If you have a mechanical group and they have a PDM, then we would here at 9.connects would highly, highly encourage you to take a look at what they've got. It is a very, very powerful system. It is handled external to SolidWorks CAD systems, so it's handled on your operating system. And let's go over some of the benefits over here. So that the typical benefits you already have that you see in the other databases, but you also get process flows as well. So if you want a new process, and like every time we start a brand new project, for example, you can set up a program within the PDM, say, I want the name of the project, and then once you've done this, I want you to put it in this particular directory, and I automatically want you to pull a PRJ file, and I want you to pull our lead schematic file, and I want you to pull our lead PCB doc file, and just put it in there, and then when they open up Altium Designer, they can continue from that point on. What's also really powerful about PDMs is that they have what's called a meta file. So every single document that you have, like a Word doc or PDF, even an Altium Designer file, there's an accompanying meta file that you have. So it's almost like an index card that gets attached to the document. And what you can do with that is you can put information in there about what this document's all about, the date it was created, who created it, and so on and so forth. Through that metadata, you can actually create process flows, because then you can write a program saying, look at the meta card. If this meta card matches something over here, then this document must have something to do with this process. And so it's really a really powerful way to handle documentation on a level that includes not just the electrical side, but the mechanical side, the system side, even the production side, if you happen to have a production side at your facility. So very, very versatile, universal solution for documentation. It doesn't matter what software you're using. So you could buy, for example, SolidWorks PDM and use it for Altium Designer. So it's not just fixed focused on SolidWorks products. It can be used for any software. And it's regardless of which design team. Again, so it can be very universal, and that's a really huge benefit of it. So what are the disadvantages? I kid you not, this is a full-time job. Learning how to work a PDM is really a career all its own. And the ones who, when you get into those really large companies that have to do what we're talking about over here, they've got several individuals who can set up these flows and run a PDM. So it's not a trivial task. You still have to create your own flows and GUI interfaces in this, because obviously you're taking it from a much, let's say, a more programming level than just having to have things pre-made for you, like a component management library or even Concord Pro. But I will note, I made this comment, kind of hinted to this comment before. If you look at Concord Pro, it is actually defined as a PDM. Well, why is that? Because it contains a directory management system. If you look at Concord Pro, they give you a bunch of different directories and directory types that you can use. You have a directory type for symbols, you have a directory type for footprints, you have a directory type for components, and so on and so forth. So it does something very similar to what PDMs can do there, and there is a database that's managing it. That's why we have a design item ID. Okay, and the only difference between this and I'll call a PDM that you would buy off the shelf is that the GUI and the scripting is restricted to the Altium environment. Now you can write scripts within Altium's environments, but you're working within the Altium environment to make this work. So in a sense, Concord Pro really does straddle that line between what I'll call a component database management system and a PDM. So that gives you kind of an overview of the different types of containers are there. As I referred to earlier today, regardless of the container, you need to add the parts that are clean from the get-go. That means you have to have consistent symbols, you have to have consistent parametric information, you have to have consistent footprints with their 3D models. Because if it's garbage in, it doesn't matter how cool the interface was, no matter how good its migration services are, in the end, if you had stuff that was missing, it's gonna still require a cleanup. There's no magical cleanup solution. So you can't feed something in and say, the system is just not smart enough to go, for example, to look at something and say, you know what, I think the part number for this is this, or I noticed that you use this symbol and I'm going to have you use this symbol instead because this is the official symbol and what you've got over there doesn't match up based off of the graphical information that I'm reading in. It just won't do that at this time. Maybe in the future, but not right now. And of course, if you do go in there to clean it up, there's a little more effort that you have to take because now you got to clean it up, but because it's under revision control, now you've got to also bump the rev. And in something like Concord Pro, for example, if I make a change to a symbol, in Concord Pro, let's say the symbol had something that I didn't like, or I wanted to add something to it, like maybe the pin direction to it. I go in there and I make those changes, and I push up the change. Well, now I've just punched a rev, so I got to fill in the form that says why I made the rev change, and automatically it's going to come back and say, well, you have X number of components that were now impacted because they were all linked to this particular symbol. Do you want to bump their rev as well? And so then you got to go through that again. Is it hard? No, they've made it very easy to do, but you've now just added another 5 minutes to the process of cleaning each and every single one of your symbols. So this brings us to a polling question here. I'm just kind of curious to know, because we're going to talk about this here in a moment, has your company ever gone through a review or a scrub of all of your components for completeness? I'm not talking about creating a new part and then simply validating it. That's really the best way to do it, but I'm talking about just reviewing the entire company library. Okay. So again, really interesting combination across the board there. I'm really surprised to hear that a lot of you actually have already been there and done that. So I guess you're kind of curious to see what our take is on that. And for those who are out there painfully going through the process of it, I hope it's going well for you. And for the good portion of you out there who have either contemplated or just new to the idea over here, strap in. It's going to get interesting. So here we go. Let's take a look at this. So what are we trying to do over here? We're ultimately trying to get the components in such a way that we get all the information, right? What we've got over here on the right side is what we want, that when we look at a database, we look at a library, even a bill of materials, that all the information is there. Nothing is missing. It's not spotty. It's not like, well, we got it here for this, not here for that. That the information is consistent, right? So it's always Sullins here if that's it. It's not Sullins, Incorporated or some other abbreviation there. So those are the kind of things we want to do. So what do we do here at 9.connects when someone asks us to basically scour their libraries or scrub them? Well, first and foremost, we do what we call staging the component. So what do we do by staging the component? We take what is given to us by the customer. Some of it could be just a bunch of different libraries all over the place. Some of it is nothing more than just bill of materials, and some of it are just a combination of these libraries, some bill of materials, and even some schematics. You're saying, like, look, extract out what you can because this is what we've got. And other times we get something that's a little cleaner than that, but we've seen it from all different angles. What we try to do is we immediately try to start from Excel because we want to see, this gives us basically that 10,000 foot view of what you've got and what you don't have at this point, especially for the parametric information. So we want to get it into Excel so we can not only see it, so we can fill in the blanks, but in all the examples I've given you, you can pretty much use an Excel sheet to get it into the container that you purchased. And there's even ways to do it for integrated libraries too through the parameter manager if you really wanted to do that. But there is a way to get this information in from Excel into these systems because they know that if you buy a container, whatever that container may be, that ultimately you do have data that you want to feed it with initially, and they don't expect you to type it in piece by piece by piece. That would be crazy. So they have mechanisms to do this, and that's what we take advantage of. The other thing that's really important is we have to get a consistent set of requirements: orientation, fonts, colors, parameter names, so on and so forth. On our website, we actually do have a whole list of those things there. And if I can, I'll see if I can pull it up during the question period. It just came to mind that we actually have this, but there's a document that you can pull down. It kind of asks all those little questions that you may want to reconcile with your colleagues before you go on a scrubbing mission here or scouring mission here. So what we wanted to show you here today is how much time does it take? Because that's a huge question. How much time does it take to do one of these things? So what I did was I surveyed 6 of my colleagues, and I asked them, and there was no one who was forced or coerced. They all did this voluntarily. They were very excited about this because no one's really ever done this that they know of. And I said, hey, I'm going to give you 9 components, so a little bit of touch of different things, and I'd like you to make these parts. Okay. And so what did we get here? So because here at 9.connect we're a small organization, I'm not saying we have necessarily dedicated designers, dedicated librarians. These are kind of their primary roles, but they can easily do libraries as well and vice versa. So two of the people who did this survey are primary designers. That's what they do for the most part, but they can do libraries. 2 of the individuals that we have here at 9.Connects, they primarily deal with library cleanup operations or understand library methodology. One of our individuals, though, very well versed in libraries and in design, it happens to be our main instructor. And then we also have an intern here as well, because I think that's important to see the data that we can get from somebody who's relatively new to Altium. So let's take a look over here. So what I asked them to do, what I said is, like, for each one of these components, I want you to research the component. How much, and more importantly, not just do these things, take the time down, write down how much time it took you to do these. So what was the time to research the component? What was the time for the symbol creation? Same thing for the parametric information, same thing for the footprint creation, and the same thing for the model. Now for the model, I allowed them to copy it if it came from an outside source, if they needed to do so, just because most of our guys are electrical and not necessarily mechanical engineers. So I allowed them to copy those. For the other ones, with the exception of these 3 resistors here, I did ask them to create the symbol and the footprint using only those tools within Altium Designer. Now I would have, and I didn't clarify this for the guys who took the survey, but if they had downloaded it from like Altium's Vault or Octopart, which are within Altium, I had to disqualify it if they didn't validate it. And one of the biggest concerns that we have here at 9.Connects is that people can easily go to a third party like DigiKey or Mouser or Octopart or Altium, and even SamAssist, and the great things that you can do. You can download them, but no one's going to guarantee that those parts are absolutely correct. So that the onus is on you to look through those things and make sure they are. So if there's a validation procedure that's in place, then I would have counted it. But in this case, he just downloaded it and moved on. Yes, they save time, but I'd still be concerned about those. Whereas I wanted to see what it takes for the individual user who's going to take responsibility to build this on their own. So that's what we've got here. I did not restrict them to colors, fonts, font sizes, mechanical layers. I didn't want to do that to them because just going through these 9 parts was already going to take about 2+ hours for each one of them, and they've got other things that they wanted to and have to do. So I didn't want to do that because I know that was going to take longer for them to do that. Here's the sheet that I basically had them do, so I just copied it into here so you can see what it was. So here are all the parts. Here was the time to do these things, and then there was also, if they had to use a method to create them, they could do that. All right, and so they just gave me the time, and then he told me how they did it. And that was really important to me, because if I saw that, for example, they had taken, if one person had taken like 65 minutes to put together the FPGA, and they said it was manual, and then another person said, well, that was 4 minutes, and I downloaded it from Altium's Vault, then okay, I get that, you did 4 minutes, but there probably wasn't a validation factor in there. And so that allowed me to see where the discrepancies were, if there was some outliers or some unusual data. Okay. Let me talk about this research part, because this part is actually really, really important. And this is where a lot of the issues come in if the data is not correct. So the first part of this is to do the research. So we gave them the manufacturer's name and the manufacturer's part number. Okay, we gave that to them. And that's a lot easier than what a designer has to do to look up something. So with the designer, they may be in a circuit and they say, well, I've got a resistor, and this resistor is, let's say, you know, I need a 20K resistor, but it's going to have to be 1 watt, and I'm okay with 5% tolerance. So now they've got to go and find a part that matches up to those qualifications, right? And that takes a lot longer. Here we basically said, look, here's the company name, company part number, go find it. And what you can see over here is that, with the exception of the Xilinx part, because there's so much information out there in these function-heavy components, for the most part, you could get this done under 2 minutes. However, and it was good that this came up, because it happens quite often with customers who ask us to help them scrub. When I initially sent out the survey, 3 of the 4 resistors were mistyped. And as a result of that, they immediately came back and said, I can't find these. So I went into our information. It took me 40 minutes to figure out what the real name was. Now, I had all the data, and I had just met with somebody, my intern, a couple hours earlier to put this all together. So I knew where all of this was. So it took me 40 minutes to do this. Can you imagine how long it would take me if I was not involved with this from the get-go? I'm figuring pi factor. If you're familiar with pi factor, it basically says whatever you think it's going to take, you multiply it by 3. So it comes out to pretty much about 2 hours for each one of these components if I could not find them. So when we go through a library scrubbing, what are we looking for? Well, the big thing for us is if the manufacturing number exists. We got that. That's really our key to filling in the rest of the information. If it doesn't exist, then we've got to go through other ways of trying to figure that out. What are these things? Well, if there's a missing number or an incorrect number, then maybe if they, let's say primarily the incorrect number, then we can try to work it backwards to see if we can figure out if there's other parts that are similar to that and then work it from there. If it's obsolete, we know that they're going to pull the data sheets. That becomes problematic. The number of options for the component type. So if we do find the data sheet or get the data sheet for it, if there's 20 different variances of that particular component, then we got to figure out which of those 20 would be the component. We can work off of hints like the manufacturer's name, the descriptions, the values. If they give us schematics, we can see where it's being used in the context of that part against the circuit. And of course, if they give us the library as well, if there's other information we can glean from the library. But this is probably one of the biggest ones that really we stumble upon when we have to go scrub a library for a customer here. Now, for time purposes, I got data on parametric input and symbol creation and the footprints and the 3D models. If you have any questions about that, feel free to ask those because I want to leave enough time for these questions here as well. I think what's really important for us to do is to look at the information as to the 6 people we surveyed and the amount of time it took them to draw each one of these. So, for example, this resistor over here, I required them to draw the symbol. They could not copy one from an existing resistor symbol. They had to draw it out over here. And you can see that that took a little bit of time. Here, the second one, they were allowed, well, the second, third, and fourth one, they were allowed to copy that symbol. But you can see that this one took a little longer because this happened to be in 0603. The second resistor happened to be in 0402. So they had to go through the footprint wizard again, or they had to manually create the footprint. So there was a little bit more time here, though you can see the time savings of having that symbol already made. These other two over here, they were 0603 and 0402 respectively. Now you have the symbol, now you have the footprint. So now it's pretty efficient to get these completed here because you've already got that information set up. The connectors are kind of interesting, even a 4-pin versus a 20-pin through hole. So the 4-pin SMT versus the 20-pin through hole, they still took about 30 minutes to do. Of course, the biggest issue with them is not necessarily the symbols because the pin number and the pin name are the same, right? So you can use the array tools to put those together rather quickly on the schematic side or the symbol side. When it comes to the footprint, you're not going to really find too many footprints or connector footprints that are going to be in the IPC footprint wizard, compliant footprint wizard. And so as a result, you're going to have to make those manually. And that's probably what took up most of the time here. When it came to these various ICs, we basically took the average of those over here just to kind of give a general average, because yes, FPGAs are obviously going to take quite a bit of time, but at the same time, you can make the argument that with the FPGAs, how many of them are you really going to pull down? Because every single FPGA you commit to is a huge commitment to your company, right? You know that they cost, they're not cheap, right? The FPGA is not cheap. You know that you're immediately going to go to possibly a 10 or 12 layer board, maybe 8, but you're definitely going to have to go more than possibly 6, depending on how big that FPGA is. And you probably got an employee who's dedicated to writing the code for that. So they're not a minor undertaking by any stretch of the imagination. So I'd be surprised if there was even more than a dozen, unless you're in a really, really large company. But if you had over a dozen different FPGAs, usually you pick 1 or 2 and you stick with those just because you know the animal that you're dealing with when it comes to those. So I think that the average we came out here is viable. So I want to go to our next polling question here. How many library components do you roughly have? You'll see why we'll bring this up here in just a moment, because we're going to do some math on what I just showed you. All right, so you can see the results there. And actually, it's an interesting thing. Before the webinar, we always talk about these polling questions, and we try to take an educated guess as to what we think we're going to see over here. And we actually would have thought that the vast majority would be under under 1,000, but actually it's a pretty decent distribution here amongst everybody here. So, and especially those who have over 5,000 components. So hopefully what you're going to find over here is interesting. So what we did based off of the information we got from our survey and what we gave in terms of the general amount of time it took each part, we said, look, if we had 1,000 parts, out of those 1,000 parts, what do we think the percentage of those within our library would fall under these categories? Now, granted, we could have easily split these into other categories. There's over 40 component categories, we just figured let's just do the main category. So discretes would be 2 or 3 pin components. ICs would be just anything like from basically your logic gates on up. Your connectors are your connectors. And then of course, electromechanical is kind of a convenient way of saying everything else. So based off of what we see on most boards, we said, well, okay, that's probably what is represented in most libraries. So we said, okay, let's break this down to certain percentages, which in turn gives us the number of parts. And again, these are the numbers that we got from our prior slide. Taking that and just mushing them into weeks, you can see that the short of it is this, that at 1,000 parts, if you had to review them all and make fixes and changes to them, you're looking at approximately 8.5 work weeks to do that. But we got to break it down a little bit further. As I mentioned earlier on, there could be parts in there that don't have proper manufacturer part numbers in that, or they're missing information that's key for you to figure out what it is. And what we have found, especially when we get involved with library services, that could be 25% of the components. So as a result of that, you could easily tack on an additional 2 weeks to this in order to make sure that you account for those parts that you don't understand why you can't find them. Are they obsolete? Did you put them in wrong? You know, what is the problem with them? Can we resolve those type of things? Do we have duplicates? That type of stuff. So now we're talking about 10 weeks full time. So the question is, can you allocate a resource for 10 weeks straight? Most of the time, no, unless you're at a really large company where they recognize they have to have a librarian. So if you can't do that, how much time can you give it per week? Well, if you give it 1 day a week at 8 hours, well, that's going to spread out to literally 1 year in order to basically go through this. And that's assuming that every week you are dedicated to that 1 day being put to libraries and you're not pushing that off. So there's also an issue with that. This is assuming that you don't have any inefficiency, because obviously there's going to be some inefficiency when you do this type of thing. If you got to pick up where you left off, then there's going to be some time to get back up to speed of where you're doing these things. It also assumes that the individual doing this is really well versed. What happens quite often is we throw an intern at this. Well, I got to let the intern do it because I got to keep my designers moving on this key project over here. Though usually your best designers are the ones who can also do the best libraries, though they probably wouldn't want to do that because they want to do the exciting stuff. But if you're going to put someone like an intern on it, like we did, I guarantee your numbers are going to almost double because they have to learn the tool and they've got to learn how to put together library parts, right? And how you think about it, we try to have them build library parts when most of them have never even built a board before. So if they haven't built a board before, then they don't know really what to expect out of the symbol and the footprint. So there's a learning curve that they've got to go through. It also doesn't take into account any retro modifications, meaning that let's say you were going along and around part 200, you realize, man, we missed a parameter that we really need to put into everything else. That means you now got to go back to the other components that you've already assessed and add that in there as well. So this is just assuming that you got everything right and you're moving along linearly in your review of all of your parts. Okay, so based on that, do you agree with what you saw here just a moment ago? So let's get that poll going. All right, so they're in. So for those people who can take less time than that, that is awesome that you can do that, and you're really blessed. For the rest of everybody, I'm at 99%. So I'm glad to see that our numbers are jiving with the way you're kind of seeing the outlook of this here. So with that, the key thing is that, yeah, everybody wants to have one of these centralized systems, but look before you leap. The container is definitely going to cost you money, unless you do the integrated library, but there's a cost of labor to do that. There's a learning curve to learn these things, right? Some of them easier, some of them much, much harder, depending on what you buy. The filling of the container is going to cost time and money, which is what we just talked about over here. How do we scrub these parts so we can get them in there? And then maintaining the container is also going to take time and money as well, because you don't want to, again, put that beautiful garden together and then all of a sudden it just goes to pot because nobody is watering it or weeding it or keeping the pests out of it, right? It's just one of those things that you constantly have to be on top of. So with that, let me talk a moment about 9.connects. And by the way, if you have any questions, feel free to write those in. And my colleague, and actually the owner of 9.connects, Christopher Che, is going to be joining us for some of these questions as well, since he's dealt with quite a few of these scrub efforts for various companies. So you're here for a reason. Number one, you want to organize your libraries. There's a value to that. Secondly, there are various options out there for you to centralize your library. Hopefully you got some ideas based off of what we talked about today. And lastly, you want to know what it's going to take to get these libraries in order. Well, what do we provide here at 9.connects? Well, here, if you purchase Concord Pro, we're very well knowledgeable of the tool here. And what we do with this is we provide kind of a two-part training if you're interested in it. Half of it is online, so that what we want to do is we don't want to give you exercises where you're coming in with a bunch of predefined libraries. What we want to do is take what you're trying to do within your company and get it up to speed. So the idea behind the online coaching is to show you what you need to do, and then as basically your exercises / homework, have you do those things. And then we meet again until we've got everything that we want all in Concord Pro. And by the way, this is not just limited to components. Concord Pro, because it's somewhat of a PDM system, it's all your files, whether it's your templates or your projects as well. And then also there's a final visit that we go to your facility for the instructions of those who weren't a part of the online efforts with the administrators there. The other thing we can do is library scrubbing, and we've done as little as 250 to 25,000 parts. And of course, everything in between, and also depends on how specific you want these things or how brief you want them as well. Some people want a lot of information added to their parts, others just want to verify that their parts look good. There are companies out there who've just given up on trying to make libraries, saying, look, we want designers to design. We want to let you handle the maintenance of our libraries. And so we do that for a couple of large companies. We are here to help. Look, we're well-versed in library management, including myself. There's 2 others here who've spent years in library management. So we get the pains that you're going through. There are individuals who are well-versed in library scrubbing. We've done this enough times to know those things that we can be very efficient at to try to get this done in a very reasonable time. So if you give us 1,000 parts, it won't take us a year, right? It may take us 8 to 10 weeks, depending on what you're asking us to do, but we can fully dedicate our time to those 8-10 weeks to do that. And the sounding board so that you can make the best decision for you and your team. We're not going to push you to L9 just because it's our product. We're going to push you to where it's going to be best for your company. So if you already came to us and we purchased Concord Pro, great. Okay, is it working for you? If you know that you have PDM, for example, and you want to know more about that, we can kind of assist with that. If you want to know a little bit more parts, we can guide you in the right direction for that. Of course, for L9, we're more than happy to sell you that as well. But the thing is that we're not here to try to push something on you. We're just here to be that soundboard so that you make the best decision for your team. So for more information, feel free to check us out at 9.connects. You can go under our engineering services, and there you can find a little bit more about component libraries. So with that, I think we're at the end of the hour. Hopefully you guys found this to be of some value to you. We'll make the recording available to you here in the next 48 hours. And of course, if you have any questions, don't hesitate to contact us. We don't want you to go out there and spend a lot of money and pull your hair out because you're going down a very difficult road.